Now we won't talk about polynomials. We will be considering expressions from the sum of integral non-negative powers of a variable x, okay, taken together with some numerical constants. And these kind of expressions are known to be polynomials. Okay, so we'll talk about the degrees of polynomials. We talk about their addition and subtraction, and then we'll also talk about the multiplication, the division of polynomials also, and then we talk about zeros of polynomials. We talk about the remainder theorem, and then with that we're able to wrap up on it. Then we talk about graphs of polynomials also. So when we say polynomials, how often do we look at polynomials? Okay, let's say we have polynomial p of x. Okay, the function of x, we have it to be equals to in the form of an x raised to the power n plus an minus 1 x raised to the power n minus 1 plus concerning up to a2 x squared plus a1x plus a0. Okay, where an minus 1 a1 a0, okay, a1 a2, sorry, I forgot a1 and a0 are called coefficients. Okay, and a0 in itself is a constant term. Okay, so the highest degree of polynomial, okay, the highest degree of polynomial is of the variable n. Okay, so n is called the degree of polynomial. Now if you look at the format of polynomial, okay, the general polynomial format, we can see that let's say polynomial px, okay, let's say it's 3x squared minus 2x plus 4. Now you will notice that n is equals to 2, so we say that this is a polynomial of degree 2. Okay, now also this was what we call as a quadratic equation. So let's take another polynomial. You can call this one p1 of x, p2 of x, of let's say x plus 1. You will notice here that the highest power of x is x raised to power 1. Okay, so that means our n is equals to 1. So you say that this polynomial is of degree 1. Okay, now let's take p of 3 of x. So let's say it's x cubed plus x squared minus x plus 1. You see that the highest power of n here is 3. So n is equals to 3. Okay, and then we have degree 3. Okay, now and it goes on and on like that. So we know what polynomials are. Okay, and how about we know what polynomials are not? Okay, now let's say we have functions. Okay, we'll now ask for them at these polynomials. Okay, let's say f of 1 of x is equals to square root of x squared plus 2x minus 3, and f of 2 of x is equals to x squared plus 2x minus 3, and then f of 3 of x is equal to 2x minus 3 is power minus 1. Now when we look at these things, okay, we realize that this f of 1 of x and f of 3 of x are not polynomials. Why? The question is why? Because they do not follow the general format of polynomials. Now px of x start from the highest power of x, okay, and the power keeps reducing up to get to the constant term a0. Okay, so with that we realize that there is no form of square root or powers of anything, always power minus 1. So this is not a polynomial, and definitely this is not a polynomial. And however, this is a polynomial. Okay, so with respect to that, let's now move on to addition and subtraction of polynomials. Okay, so it's just like having simple addition going on. Okay, so we take it's like having coefficients. Okay, we take collect like times all together. So let's say addition and subtraction of polynomials. So let's say we are given two polynomials or three. Okay, let's say p1 of x is equal to 7x raised to the power 3 minus, again, minus 4x squared plus 3x plus 4, and let's say p2 of x is equals to 5x squared plus 6x plus 1, and then p3 of x is equals to 4x cubed plus 2x minus 3. Now we have series of questions. Okay, so we have p1 of x plus p2 of x, and we have p1 of x plus p3 of x, and that's all for addition. And let's say we have p1 of x minus p2 of x, and then we have p2 p1 of x minus p3 of x. Now in that case, so it's very easy. It's just like normal algebraic equations and all. So now we waste much time on that. X p1 of x plus p2 of x. Okay, so that means p1, write the whole of p1, 7x cubed minus 4x squared plus 3x plus 4. Okay, well, we add it to p2, that's 5x squared plus 6x plus 1. Okay, so in this case, all we just want to do is bring all the x squared together, bring all the x cubed together, bring all the x together, and bring the coefficient all together too. So that means we have 7x cubed. Let's open the bracket first. Plus minus 4x squared plus 3x plus 4 plus 5x squared plus 6x plus 1. So 7, apart from 7x raised to the power 3, there's no other 7x raised to the power 3 minus 4x squared. So we're going to realize that we have 2x squared. So we have minus 4x squared and we have plus 5x squared. And now we want to move to the x. So we have 3x, we have 6x, and then the coefficients. We have 4 and also we have 1. So that's plus 4 plus 1. So that will give us 7x cubed minus 4x squared plus 5x squared is 1x squared. So that's plus x squared, and then plus 3x plus 6 will give us plus 9x, and this will give us plus 5. Alright, so easy peasy. And then we can also have number 2, p1 of x plus minus p2 of x. Okay, so you know that our p1 of x is 7x cubed minus 4x squared plus 3x plus 4, and we want to subtract 5x squared. Okay, plus 6x plus 1, and with respect to that, we open the bracket with a negative sign. So 7x cubed minus 4x squared plus 3x plus 4, where we open the bracket with a minus sign. So we have it to be minus 5x squared minus, because negative times positive will give us negative, so minus 6x minus 1. So as usual, we start with the highest power. So here we have only just a representative from x raised to the power 3, and then we move down to x squared. So we have 4x squared and we have 5x squared minus 5x squared, and we have 3x, and we also have 6x. Okay, and then we have 4 and we also have minus 1. So this will give us 7x squared minus 9x squared, because minus 4 minus 5 is 9, and minus 3x plus 3 minus 6 is minus 3, and plus 3. Okay, so we do the same thing with the subtraction. So we have p1 of x minus p2 of x. Okay, now p1 of x, as we know, is oh my god. Okay, we solve p1 of x minus p2 of x. Oh, okay, so we can just call this number 3. We can call this number 2. Okay, so now we want to solve p1 of x plus p3 of x. Okay, so in our question, our p1 of x is 7x cubed. Okay, we also have it here. So 7x cubed minus 4x squared plus 3x plus 4, and our p3 of x is 4x cubed plus 2x minus 3. That's 4x cubed plus 2x minus 3. So in that scenario, we open the bracket with the plus sign. Okay, so that will give us 7x cubed minus 4x squared plus 3x plus 4 plus 4x cubed plus 2x minus 3, and then we taking the like times on each. Okay, so that means we have two x raised to power 3 components. So we have 7x cubed plus 4x cubed, and then we have just one x squared minus 4x squared, and then we have 2x plus 3x plus 2x, and then we have two coefficients or constants now, plus 4 minus 3. So 7 plus 4 will give us 11x cubed minus 4x squared. 2 plus 3 will give us 5, and then 4 minus 3 will give us 1. So now move up to question 4. Alright, so question 4 is p1 of x minus p3 of x. So in that scenario, we want to just say is a 7x cubed minus 4x squared plus 3x plus 4 minus p3 of x also is this, so minus 4x cubed plus 2x minus 3. All right, so having established that we have it, we just open the bracket with minus 4x squared plus 3x plus 4 minus 4x cubed minus 2x plus minus times minus will give us plus, and that will give me plus 3. Yes, now give me plus 3. All right, so realize that we have 2x raised to power 3, that's 7x cubed minus 4x raised to power 3. We have just a single 4x squared minus 4x squared. We have plus 3x, and we have minus 2x plus 3x and minus 2x, and then we have plus 4 and plus 3. Okay, so with respect to that, we have it to be what? 7 minus 4 is 3x cubed minus 4x squared. 3x minus 2x will give me 1x, that's minus x, so plus x, and 4 plus 3 will give me 7. So that will be all for this question, and we can also increase the question further. What if we have something like a scalar multiplication for the question? So let's say we have p1 plus 2p2 minus 3p3. So the question is, how do we go about this? So we can just 5 and p1 of x plus 2p2 of x minus 3 p3 of x. Now we know that our p1 is this is our p1 written here. Okay, so we have it to be 7x cubed minus 4x squared plus 3x plus 4. Okay, within brackets plus 2, and then we'll find our p2, and our p2 from the question is 5x squared plus 6x plus 1. Okay, our p2 from the question is 5x squared plus 6x plus 1 minus 3 into p3, and this is our p3 here also. So that will be 4x cubed plus 2x minus 3. Alright, so in that case, so we'll have it to be 7x cubed minus 4x squared plus 3x plus 4, and then we now open the bracket to plus 2. So 2 by 5x squared will give us 10x squared, and 2 by 6x will give us 12x, and 2 by 1 will give us 2, minus 3, open the bracket with minus 3. So minus 3 multiplied by 4x cubed will give us minus 12x cubed, and minus 3 multiplied by 2x will give us minus 6x, and minus 3 multiplied by minus 3 will give us plus 9. So now the way forward now is to collect like times. Okay, we can see that we have starting with the highest power, where we have 7x raised to the power 3, and we also have minus 12x raised to the power 3. So we can bring them together. 7x raised to the power 3 minus 12x raised to the power 3. Then let's go for the x squared. So we have minus 4x squared, we have plus 10x squared, and we have that's all. Sorry. So we have minus 4x squared and plus 10x squared. And then afterwards we deal with the x variables. So we have plus 3x plus 12x and minus 6x plus 3x plus 12x and minus 6x. And finally we have plus 4x plus 2 and plus 9. Those are the constant term, plus 4 plus 2 and plus 9. So 7x cubed minus 12x squared. So that's 7 minus 12. That will give us minus 5x cubed, and we have minus 4x squared plus 10x. So we have these, and this. So minus 4 10x squared will be plus 6x squared. 3 plus 12x minus 6x. So 3 plus 12x will give us 15x minus 6x will give us 9x plus 9x, and 4 plus 2 will give us 6, and 6 plus 9 will give us 15. So this will be our final answer. So questions can come in handy when based on addition, subtraction of polynomials. So it is very important to have a good background on it. So in our next video we will talk about substituting a value for x in the next polynomial, and then we'll talk about also multiplication of polynomials and division of polynomials. All right.